This example is going to be a situation where you're not going to really be able to avoid doing a quotient rule. So you actually start out with your power rule, because your power is going to be your outside function. All of this is your inside function. So this is where your quotient rule is going to come from. So not anything to bother rewriting. Alright, so starting with your power rule, you would do 2 times your function to 1 less power, which means this would just go down to a first power. Okay, now you have to take the derivative of the inside. This is where your quotient rule is going to have to be applied. So, of course, to show the multiplication, I'll just do another set of parentheses. So now going with quotient rule, you would have low D high minus high D low over low low. Okay, so now getting this simplified. First of all, working here in the numerator of where you've done your quotient rule, the simplifying that you can do there. So distributing the 2x to these two terms, so that would give you 2x to the 4th plus 4x. Now, of course, this is just a monomial times a monomial, so you won't have to worry about distributing the minus sign. So that would just be minus 3x to the 4th. Okay, now your 2 that you have out front here is understood to be over 1. So you have 3 fractions to multiply. So like you have this numerator times this numerator times this, and of course the multiply your denominators together as well. Alright, so across the top, I'm just going to go ahead and start writing it as just one single quotient. You would have 2 times x squared times, now over here this is going to, of course you can combine these two together, but then you're still going to have 2 terms, so we need to put it in parentheses. So I would have a negative x to the 4th and then plus 4x. Now when you multiply across the bottom, of course the times 1 doesn't change anything, but if you notice this expression is the same as this. Now you can put this in parentheses, which means it's understood to be to the first power. So you've got 1 of them here, you've got 2 of them here. So when you multiply, you add your exponents. So that means now you're going to have it to the 3rd power. One last step that you could do is take your 2x squared and distribute. And really, I mean, you could distribute or not. It's not going to make a big difference. Answer in the book will have it distributed. So I would have negative 2x to the 6th plus 8x to the 3rd divided by x cubed plus 2 minus 3. Now I said the back of the book will have it distributed. I think it does. I'm not 100% sure without looking right now. But, you know, these would both be acceptable answers because nothing's going to end up canceling out. Alright, the next examples that we're going to start looking at will involve using your chain rule with your trig functions. Now, you do have 2 functions here. What is considered to be your outside function is going to be your sine function. Your inside function is going to be the argument. You know, a lot of the times, well, going back to any of the trig stuff that we've done so far with derivatives, all that you've had here is just an x, but as you can tell, now I have pi times x. So this is your inside function, this is your outside function. Alright, so taking your derivative, remember you always start by taking the derivative of the outside. So the derivative of sine is cosine. Alright, so when you do that step where you're taking the derivative of the outside, whatever your argument is here, that needs to be left the same. Now you're going to multiply this times the derivative of the inside. Now remember, the part that I've circled here is the inside part. Now pi is just a number, so like that's the coefficient of x. So just like we've seen with the other examples, if you just have x to the first power, then the derivative, like if you go through your power rule, will end up being just the coefficient. So this would just be pi. Now you can't combine this pi with this because you can't combine anything in with your argument. Answer in the back of the book is just going to move this pi to the front, and it's just going to be treated like a coefficient. So you'll have pi times cosine of pi x. But something I want to point out, a mistake that I see students make, is when they take the derivative of the trig function, they want to go ahead right here and also take the derivative of this at the same time. But when you're doing the trig function, you keep the argument the same, then you multiply by the derivative of the argument. Okay, next one. Alright, so this time your trig function is cosine, which means all of this is your argument. So like this is your inside function, this is your outside function. Okay, so outside function first. So the derivative of cosine is negative sine. But remember, when you're doing this, you keep the argument the same. Okay? Now you multiply times the derivative of the inside. Alright, so the derivative of this part that I've circled, of course that's the inside, this is going to require chain rule because you've got this to this power. So actually you have two inside functions that you have to deal with. What? Okay. Okay, so your innermost function is the 1 minus 2x. So, like I said, starting with your power rule. So you have to do 2 times your function to 1 less power. So that would, of course, drop down to just a first power. Then you have to do chain rule again and take the derivative of the inside here. So the derivative inside here is negative 2. So you can have to use chain rule multiple times. It's not always just two functions where you have an inside and an outside. You know, you always have that outside function, but then you know, within your inside function, you may even have another inside function. Alright, so just simplifying this up a little bit. Of course, this is negative 1 times 2 times negative 2, so that's going to end up giving you a positive 4. Now, this expression is the same as this, but this doesn't combine with this because this is the argument of your trig function. So let's just go ahead and write this next. And now write the trig function. So this ends up being your final answer. Now, if you distribute the 4 through here, that's perfectly okay. Again, that's just kind of one thing that can be done different ways. Okay, now, on this one, you notice the square is written in between, which means it's your trig function that's being squared this time. Let me pull this one back up. See, the square that I had here, this square is only on the argument. This does not mean the trig function's being squared. So whether it's located here or here, that's two different things. So on this one, I am going to rewrite it. I think it'll make a little bit more sense if you look at it this way. Okay, now you can take your exponent from here and put it at the end, but if you do that, when you raise it to the second power, you have to make sure you include the trig function and the argument all in parentheses to the second power. So when you're talking about inside and outside functions this time, this is actually your outside function. So you're going to start by doing your power rule. And then you'll have your cosine function will be like the next inside function, and then this will be even inside this. So this has like 3 layers like I was talking about a while ago. You're going to have to do your chain rule twice. So you have an outer function, inner function, and another inner function. Alright, the 5 is just a constant multiple. So we can just do 5 times, just bring it down. So starting with power rule, you're going to do 2 times your function to 1 less power. So that's just going to drop down to a first power. So you wouldn't have to put another set of parentheses to the first power. Times. Now remember I said the next inner function is going to be the cosine. So the derivative of cosine is negative sine. Now when you're doing the derivative of the trig function, remember you keep the argument the same. Now you do the next layer of your chain rule, which is the innermost function, which is the argument. So the derivative of pi x would just be pi. Alright, so of course 2 times or 5 times 2 is 10. Of course, you can go ahead and multiply times the negative 1 and multiply times the pi. So say that we have negative 10 pi, and then you'll have cosine of pi x times sine of pi x. Now, it doesn't matter whether you write the sine first. Okay, I didn't mean to put that parentheses right there. I meant to just keep it around the argument here. But it doesn't matter, which of these two you write first. They're all being multiplied, so it'll be fine either way. All right, one more trig function. All right, so going back way at the beginning, I've got a difference, so I will be able to take the derivative of this term and this term separately. So dy dx. So the derivative of 3x would just be 3 minus. Now the 5, again, is just like a constant multiple, like we saw a while ago. Alright, now, let me compare these two again for you. If you notice the square here, the location means when I rewrite it, the whole trig function and everything is to the second power. But this time, the square is only on just the argument. Okay, so I actually am not going to start with my power rule this time. What's going to be my outside function is going to be the cosine, because this is not this entire thing to the second power. So the derivative of cosine is going to be negative sine. Okay, now remember, when you take the derivative of the trig function, the argument portion of it stays the same. Now, you got to take the derivative of the argument. Okay, so like this is your argument. So when you start to take the derivative of this, now you start with your power rule, and you're going to have 2 times the function, which is the pi x. And of course, that just drops to a first power. But then you have even a function that's even one step further in as far as your inner function, and that's going to be the pi x. So now you have to take the derivative of pi x, which is just pi. Alright, so we have 3 minus. Okay, I can multiply the 5 times the negative 1 times the 2 times the pi times the pi. I mean, all that's being multiplied. So this actually we can change to plus, because this will end up making it negative. So minus a negative we change to plus. So 2 times 5 is going to give me 10. The pi times the pi we can just write as pi squared. And then we've got the x, and then we have sine of pi x squared. So this would be about as simple as you could take it.